All right, for number 16, all right, a ship sails 125 kilometers west. So now, so we are doing navigation, and we're going to see some degrees and make sure that 0 degree is pointing north. Okay, that's what we do when we do direction bearings. Okay, and the east is 90 degrees. Okay, so a ship, it's gonna sail to the west direction for 125 kilometers, and then followed by 100 kilometer on a bit with along a bearing of 320 degrees. So I'm gonna draw and a cross right here. Okay, and then 320 degrees will be somewhere right here, and that's 100 kilometers. How far is the ship from its starting point? What's the bearing of the ship from its starting point? So it asks for both the magnitude of the resultant and also the direction. So we want to know how long this purple vector is, and what is this angle? What is this angle theta right here? Okay, two things. So don't leave out one of the two, okay, when you answer the questions. Well, we got two sides. Let me also label the angle here. This is 320. Just out of curiosity, what is this angle? It'll be 40, right? So that means this big angle would be 130 degrees. A little bit of curiosity would carry you a long way. And hey, can you see what we can do now? Law of cosines. Okay, so you're going to use law of cosines first. Okay, so x is equal to square root of 100 squared plus 125 squared minus 2 times 100 times 125 times cosine of 130 degrees. And that would be 100 squared plus 125 squared minus 2 times 100 times 125 times cosine of 130 degrees. And then raised to the 1/2 power, which means square root of that number. So I got 204.193. Okay, so that's a length. 204.193 kilometers. That's pretty easy. Okay, I think the hardest part is, can you tell the obtuse angle right here, the 130 degree? Okay, do you know you have the hints? Okay, the little ingredients to pull things together. And now, what about the theta? What's the angle here? Well, again, like I said for the past day, or yesterday, is that I want you to acknowledge one thing. That is, if you have all three sides and you have one angle right here, you can solve for the triangle. You could tell every single thing about this triangle. You can tell the remaining two angles by using the law of sines or the law of cosine, either way, but you can find it out. So if you want to find out the degree, the theta right here, so the only thing we are left is that we want to know this little slice. If we know this angle, then we can add on to 270. Okay, I mean, like for example, if this is 25 degrees, then the bearing would be 270 plus 25, right? If. So let's find out what it is then. So let's call this theta prime. So we'll say, we got some angles, we got some sides. Let's go ahead and use law of sines. So sine theta prime over 100 kilometers. It's equal to sine of 130 degrees over 204.193, the one we just found. Okay. So sine 130, sine of 130 degrees divided by 204.193, and then times what? Times 100. Okay, so that's what sine theta is. Okay, sine theta prime, it's 0.3751. So sine theta prime, it's 0.375157. So the inverse of this number would give us the angle, and the angle is 22.034. So that's the theta prime. And with this theta prime, we now can say, well, the actual bearing, the actual theta, it's going to be 270 degrees plus 22.034, which is 292.034 degrees. Okay, so drawing, it's very important. And again, draw a big picture. Do not draw a tiny picture. Okay, do not draw a tiny picture.